Hello, this video is for in class on the block day, February 11th and 12th. It goes with the Holt 9.1 bookwork. We're going to review a few things we talked about in class Wednesday. So first thing to review is a quadratic function. This is any function in the form y is equal to ax squared plus bx plus c. And a parabola is the graph of a quadratic equation. It takes that U shape or is curved. And then on the bottom here, I included a little diagram. So if you remember that a value right there in the front of our equation is important, it tells us whether our graph will open up or if it opens down. So this one opens up on the left there because a is greater than 0. And when a is less than 0, we call it a sad face. It opens down. So whatever that value of a is, positive or negative, is important. Okay, let's look at this parabola we've been given. We actually have the equation too, so it says f of x is equal to negative x squared minus 2x plus 3. So it first asks, do we have a minimum or a maximum? If I look at my graph, it's opening down, so that must mean that it reaches a maximum. And remember, when I ask for a min or a max, I want to know the value of the y. So if I'm looking for a max, it's right there at the top of my parabola, and that would be y is equal to 4. Now the vertex is at the same spot. It's this top part right here, but I have to list the ordered pair. So that would be negative 1, 4. Axis of symmetry. Now, I don't think we talked about this in class necessarily, but the axis of symmetry is kind of the middle of the parabola or the halfway point or the place where the reflection happens or the symmetry happens. So in this case, that axis of symmetry is going to go right down here. Your axis of symmetry is actually goes through the vertex as well, so I can help identify it. So my axis of symmetry here would be x is equal to negative 1. And then does it open up or down? Well, it points down, it's sad, which means that a must be less than 0, and it is. If I look over here, a is a negative 1. Okay, something new. We also have to be able to tell from a table if a function's quadratic. So what we're going to do is we're going to use the second difference, or the difference of the difference. So what we're going to do, we're going to look at our x's, and as long as those are going up by a constant, which in our first table they are, we're going up by 1. We're going to look at the second differences in the y's. So let's do an example to check it out. So I'm going to do my first difference. So to get from 0 to 1, I add 1. To get from 1 to 4, I add 3. 4 to 9, I add 5. 9 to 16, I add 7. And then 16 to 25, I add 9. All of the ones in pink I just wrote, those are my first differences. So I have to do this one more time to get my second differences. So between 1 and 3, that's adding 2. Between 3 and 5 is adding 2. Between 5 and 7 is adding 2. And between 7 and 9 is also adding 2. So my second differences in black are all equal. So that means yes, this one is quadratic. Okay, let's look at our next one. So my x's are going up by 1 again. We're good there. So I'm going to check y's. So I have a plus 3, plus 3, plus 3 from 2 to 5, and another plus 3. So some of you might be asking what's happening here. So technically, I mean, the second differences are constant because it would be 0 between all of those. But if second differences are 0, it's not quadratic anymore. If you think about this, we have a constant first difference. So this is not quadratic. It is actually linear. So watch for that. If the first differences are constant, it's linear. If the second differences are constant, it's quadratic. All right, let's look at some graphing. We are going to learn how to graph just using a table first. So here's my x and my y. Oops, it's a little sloppy. And later on next week, we will learn some other strategies for graphing as well. For graphing quadratics, we generally want to have at least 5 points on our graph. It's kind of a guideline. If I don't know where to start, there's some basic x values I usually try. So I usually try x being negative 2, negative 1, 0, 1, and 2. After that, if I feel like I still don't have a clear picture of the parabola, I will go back and add more points as needed. So plugging in just x is -2. So if I do that, I have -2 times -2 squared minus 4. It gives me -2 times 4 minus 4. Well, that's -8 minus 4, so that's -12. Okay, do the same thing with -1, so I get -2 times -1 squared minus 4. Gives me -2 times 1 minus 4, which is -2 minus 4, which is -6. Plug in 0. That one's pretty easy because the first term just becomes 0, so that's a -4. Go ahead and plug in, let's do +1, so I get -2 times 1 squared minus 4, -2 minus 4, -6 again, and then if we plug in +2, excuse me, you're going to get a -8 minus 4 again, so -12. Some of you guys maybe notice there's some patterns here. Remember that parabolas have symmetry, so it's not a coincidence that, for example, both x being 2 and -2 give us a y of 12. So I'm going to go ahead and plot those points. Some of them go a little bit off, so we'll do the best we can. 0, -4 is going to be somewhere in here, and then we're going to do -1, -6, and then somewhere down here for the 12, 1, -6, and then 2, oops, that one should be a little bit lower to match the other one. You guys, it should be a little bit neater on your paper than on my iPad. And then I'm going to draw my curve through that, so know that it's going to be opening down, which I knew because that is a -2. So it's going to go through my points. Again, yours should be a little bit neater. With the 5 points I drew for this graph, it gave me enough to see where my parabola was. If it hadn't, I would add more. Alright, let's look at our next one. So y is equal to x squared plus 3x minus 2. So again, I'm going to start with those same x values. And I'm going to plug them in to see what happens. So if I plug in a -2, I would get 4 minus 6 minus 2. So that's going to give me a -4. If I'm going to do -1 next, I'm going to get 1 minus 3 minus 2. So that's going to give me a -4 also. If I plug in 0, well, x squared, 0 squared is 0, 3 times 0 is 0, so that's just a -2. Plug in a 1, I'm going to get 1 plus 3 minus 2, so that gives me a +2. And then for 2, I'm going to end up with 4 plus 6 minus 2, so that's going to give me 8. Some of you guys notice something interesting. You're like, wait, it's the same for -2 and -1. What that tells me is that my axis of symmetry is going somewhere between -2 and -1. So I'm going to add another value on the other side there. I'm going to put -3 just to see what I get. So for that one then I would get 9 minus 9 minus 2. That gives me a -2. So I think I have a pretty good idea of what my graph's going to look like. I'm going to start graphing. So I'm going to start at the -3, -2 is going to be somewhere. Again, you guys can do yours a little neater right there. -2, -4. And then I have a -1, -4. Then I have 0, -2, 1, 2, 2, 8. So I can see my parabola shifted a little bit. I can't see the whole left side of it, but it should mirror the right side that I can see coming right through here. So I'm going to get a best guess there. I can see my vertex again is somewhere down there. I could plug in some x values in between -1 and -2 to get a more exact sketch there, but for now this works. We're going to keep practicing. You'll notice I added domain and range at the bottom. Domain and range are important, and we're going to talk about them again now. So for parabolas, whether they open up or down, if we're just looking at a plane graph, so like this example and the example on the previous slide, they're just equations with graphs, no like word problem. The domain is always going to be all real numbers. Remember, those are your x values. or if you want to, you can say ARN. Now, when dealing with word problems, we might limit our domain, so we maybe only use real numbers if we're talking about time, for example. Our range is going to be a little bit different. Remember, range deals with y. So in this case, if we look at our graph, we know our graph reaches a minimum. And I'm going to say that's about, let's just say about 5 right there for estimation purposes. That should be a negative. So it's about a negative 5. Any other value on this curve, as we go up and down the parabola, the y value has to be greater than that negative 5. So here the range would be y is greater than or equal to negative 5. Whenever you have a minimum, your range is always going to be y is greater than or equal to whatever your minimum is. Okay, a couple more domain and range. Just plain graphs, so my domain is going to be all real numbers. I'm going to do ARN. If I look at my range, I can see I have a minimum here at y is equal to 3. So any other point on that parabola is going to be greater than 3 for my y. Like points up here, here, here. The y values of any points are going to be greater than 3. So range is y is greater than or equal to 3. Let's look at our next one. This one opens down. Range is still all real numbers. But now I reach a max, and that looks like about 8 is where that max is. So any other point on that parabola now has to be less than the maximum, because 8 is the max. That's the biggest y value. So any other y has to be less than that. So y is less than or equal to our max, which is 8. After you guys are done with this, go ahead and get started on the Holt 9.1 bookwork. Please feel free to email me if you have any questions. Thanks.